Hey guys, Nathaniel here. In this video, I'm going to be showing you how I created a relay incentivization protocol for Nostr. Now, Nostr is a simple open protocol that enables global decentralized social media. As you can see, this is the substrate contract UI which I'll be deploying and testing my Nostr contract on. It is also connected to my local node. So I'm going to upload this. Right, now we can see a few of our contract functions like the create subscription plan, which the relayer creates a particular subscription plan on the contract. We can see the subscribe to plan function, which the user subscribes to a plan ID created by the relayer. You can see the get subscription plan function that returns the available subscription plan created by the relayer. It returns nothing because we've not created a subscription plan yet. We can see the get subscribers also returns nothing. So first we want to create a subscription plan, and let's say we want to create a weekly subscription plan for 150 units. Okay, now if we were to call our get subscription plan, you can see it returns the plan ID, the relayer ID, the duration, the price of the duration. So it is 150 units per week. Now we want to subscribe to a plan ID, the plan ID created with our Nostr public key, and it is the user that calls this. It's subscribed to the relayer. Okay, so we want to get subscribers to see whether, okay, now we can see that our subscription has been accepted, and this subscription ID, the user subscribed to the relayer with its Nostr public key. This is the duration, this is the start date, and the expiry date. We also have here the get total earnings function for returning the total amount of money the relayer has earned from subscribed users on the contract. As you can see, it's just 150. I imported the palette schedule for my contract because I use it in some functions like the subscribe to plan function. Anytime this function is called on the contract, there's a background task that tells the contracts to pay the relayer a certain amount of money once the subscription plan is over. And we have the report function for users to report the relayer to the contract for data unavailability. Maybe the relayer wants to fetch one of its previous posts and it's no more available. They impute the relayer's byte address and the receipt, which is the signature of the post, because subscribed users have access to their post being accepted on the client by the relayer, and the relayer hashes the post and signs the post and stores the signature, and the user can retrieve the signature of their post and use it to report the relayer to the contract. There's also a background task here that waits for the relayer's response, because the relayer can challenge a report by sending the user's post to the contract. But ideally, a relayer should not be sending the full post to challenge a report every time, because that is like a lot of data. It is just supposed to send a summarized version of the post. So I'll be implementing something called KZG polynomial commitment scheme. It is used to prove something without revealing the underlying value. Or I could use something like a Meko Pro for this type of situation also. It is what I'll be implementing in my next updates for my project. And here we have lastly our get report function for getting a pending report or a successful report. Reports that the relayer sends the user's post are cancelled, and reports that the relayer does not send the user's post within a designated amount of time are penalized by the contract, which means they are deducted from their earnings per that subscription plan. In my next update, I'll also be implementing a custom payment processor, because currently LNBit is implemented as the payment processor and there are no extensions designed for integrating with substrate-based token where the contract can actually pay the relayer its money that it owns. Yeah, so I'll be testing the updates with a Nostr client. Now this is my local relay. I wrote a test for the whole setup. In the test we have 3 public keys: the contract public key for querying the contract functions, the client public key and the relay public key. So we query the get subscribers function on the contract and get the user's Nostr public key and match with the public key gotten from the client. If they match, the user is subscribed, and we start accepting posts from the user. And we also I also wrote a test for listening for report events on the contract that matches its public key. So if we cargo test here, would see that all the tests are running perfectly. There are other tests for different purposes also. So this is the diagrammic representation of the whole setup. So what it basically does is that the user subscribes to the relayer with its public key. The Nostr relay queries the contract for public key and matches with the client, and before it starts accepting posts from the user can report the relayer to the contract for data unavailability. The Nostr relay listens to report events on the contract that matches its ID and challenges the report with the user's post. Thank you guys for watching this video. I hope you guys enjoyed it. See you next time.